Alright, geometry. So today we're talking about similar figures. Before break we talked about ratios and proportions, but today we're going to actually start talking about similarity. Similar polygons are polygons that have the same shape, but not necessarily the same size. So when we talk about congruent polygons, we're saying that they have the same size and shape, but similarity means that they have the same shape, not necessarily the same size. So to be similar, all the corresponding angles are congruent. So the angles have to be the same, but the side lengths, all corresponding side lengths, need to be proportional. So if you look at this picture here, on these shapes, let's go ahead and label them A, B, C, D, and E, F, G, H. So on these two shapes, you have to have the same angles. So A would have to be congruent to E, B to F, C to G, and D to H. The angles have to be the same. The side lengths, obviously, I know I tell you not to assume, but look at the side lengths. They're obviously not the same. But what we do know is that they're similar because their angles are the same. And this symbol right here means similar. So what this phrase over here means is that A, B, C, D is similar to E, F, G, H because the angles are the same, the side lengths are proportional. Okay, let's move on to our first example. In the diagram, triangle RST is similar to triangle XYZ. It says list all the pairs of congruent angles. Because they're similar, we know that the angles have to be the same. So that means that, if you look at this picture, T has to be congruent to Z. When we talked about congruent triangles, we talked about corresponding angles. Those are the ones that correspond, because if you look at the order of the letters right here, T is in the same spot as Z. R needs to be congruent to X, and S needs to be congruent to Y. So those are your corresponding angles. We're going to go ahead and write those down. Okay, so here's our pairs of congruent angles. Now we're going to check that the ratios of the corresponding side lengths are equal. Remember, you can always figure out which sides are corresponding by looking at the order. So like RS is corresponding to XY because of the order of the letters. If it's not obvious from the picture, because I know we don't want to assume, but you can look at the order of the letters if you need to. So let's check our side lengths. Let's start with RS. We know RS corresponds, so RS is 20. RS corresponds to XY, which is 12. We want to simplify that ratio. That's what we did right before break. So these both divide by 4. So if we divide both of those by 4, then we're going to get 5/3. Okay, we need to do that for all 3 ratios. So let's now do TR and ZX. TR is 25. ZX is 15. I know that both of those numbers can divide by 5. So I'm going to do that. And when I do that, oh my goodness, we get the same thing, 5/3. And then the last one, TS and ZY. That's going to be 30 over 18. Highest number of those divide by is 6. That simplifies then to, you guessed it, 5/3. So we're checking to see that our side lengths are proportional, and I'm going to go ahead and highlight them now. They all simplified down to 5/3. So are your side lengths proportional? Yes, Mrs. Brandt, they are. Awesome. Okay, last thing is a statement of proportionality, which is kind of weird. What we do is we say which side lengths correspond to which other side lengths in this big, long equal sign. So on Big Ideas Math, you're going to probably drag and drop to make this easier. but we're going to write this down as one long equation, so to speak. So on the top, I'm going to have triangle RST, and on the bottom, I'm going to use the side lengths for X, Y, Z. Okay. So let's start, and it's kind of like what we did with the proportions there. We checked that they're proportional, and now we're going to say that they actually are. So your side lengths are equal, your angles are equal, but your side lengths are proportional. So here's your way to say that. We know that RS corresponds to XY. And I'm going to go ahead and highlight these as I go. So RS to XY. We know that RT corresponds to XZ. Okay, write that down. And then the last one, TS corresponds to ZY. It does matter the order of the letters, right? We talked about this before. So you've told me here's the stuff that's proportional. Here's what side goes with what. That's basically what you're telling me. And now last thing, this is probably the trickiest part about what we're doing today. You've actually seen scale factor before when we did dilations last semester. Scale factor is the ratio of the side lengths of, okay, sorry, we got a typo here. Scratch that out, of the two corresponding sides of a polygon. So you need to figure out, here's a simplified way and what we talked about last semester. Scale factor is simply this. It's what you multiply by. So the scale factor should be reduced to the lowest term. So if you have a fraction, make sure it's simplified down. I need you to know that scale factor is represented by K. All right. We are going to determine whether these polygons are similar. If they are, we will write a similarity statement to determine and find the scale factor of CDE to TUV. All right, we need to check, are the angles the same and are the side lengths proportional? Well, let's look at these triangles, right? If you look at those triangles, the angles are marked congruent, so check, we have that. Now we're going to check that the side lengths all divide down to the same thing or simplify down to the same thing. So 5/4. I'm going to go ahead and use decimals on this one since we have a weird decimal side. It'll probably make it easier. So 5 corresponds to 4. I'm going to write that down, and I want you to go ahead and divide that in a calculator somewhere. If you do 5 divided by 4, you could use your computer, you could use your phone. You're going to get 1.25. Okay, check. Let's do the next one. 10/8 divided out. You should get 1.25. Check. And now the last one. This is why we're using decimals on this one, just because this side is kind of weird. 12/9.6. Divide it, please. I'll do the same. You get 1.25. So all of your side lengths, all your proportions or your ratios are going to divide down to 1.25. Your angles are all the same. So yes, these two shapes are similar. We're going to write a similarity statement. A similarity statement tells us, just like a congruent statement, if you remember when we did congruent triangles, you need to tell me that the triangles are similar. Triangle CDE is similar to triangle TUV. Okay, before we move on, it says also find the scale factor of CDE to TUV. So we're going from this triangle to that triangle. This can be kind of confusing. You're trying to think about what would I have to multiply by to get from CDE to TUV. you're going to have to multiply by a number that's smaller than 1 because the side lengths are getting smaller. So in order to do that, let's look at this side and this side. You need to go from 5 to 4. 5 times the scale factor equals 4. Now you already know, you might know in your head like what that's going to be, but to actually solve for it, you divide by 5. And now we know that the scale factor is 4/5. So it's the ratio, if you remember from the front, it is the ratio of the lengths of the corresponding sides of a polygon, and it should be reduced to the lowest terms. So if you can simplify the fraction, you should. So my scale factor is 4/5. This is our scale factor. We're going to move on to number 2. In the diagram, ABCD is similar, that's what this symbol means, remember, to QRST. What's a scale factor of, this is important how it's worded, QRST to ABCD. So we're going from the little one to the big one. So we should be multiplying by some number that is greater than 1. Okay, here's how we think about it. You're going to go, let's look at the smallest sides. Well, not small sides. It doesn't really matter what sides you look at, to be honest. Let's look at QT and AD. So QT and AD. Those are corresponding sides. They should be proportional to one another. And you can look at all the sides. You should see that there's a pattern here. To go from 5 to 10, you multiply by some scale factor k. Think to yourself right now, what would I have to multiply by to get from 5 to 10? Hopefully you've thought about it. You multiply by 2, right? So that means that my scale factor k is 2. You can get the exact same thing by dividing by 5, just like we did up here. But if you also just think about it, our scale factor is what we multiply by, right? So we have to multiply by 2 all the side lengths. 6 times 2 is 12. 4 times 2 would be 8 for that missing side, and 8 times 2 is 16. Now this is where we're going to go back to what we talked about before break. This is why I made you solve proportions before we left for spring break. We're going to find the value of x, and the best way to do that is to write a proportion and cross multiply. All right, you have to take a proportion or a ratio that you already know. So I'm going to use 5 over 10 since we've just used that. 5 over 10 equals, okay, notice how this was small, large. You have to keep it the same whenever you go to do this. Some of you can do this with using the scale factor instead. If writing proportions seems like too much work, fine. Use the scale factor and just multiply. But it gets more difficult, which is why I'm going to teach you how to do it like this here. 5 over 10 equals, all right, we are looking and we're trying to solve for x. 4 corresponds to x. So the other ratio would be 4 over x. Again, small side over the large side. Now you cross multiply. 5 times x is 5x. 10 times 4 is 40. And solve. So we need to divide by 5. So x equals 8. So that missing side length is 8. You could get the same thing by just doing this side 4 times the scale factor 2 to get 8. If that makes more sense to you, great, go for it. Last example, we're going to find the value of x. Again, you're going to see me do this by writing the proportion. If you would rather figure out what you would have to multiply by and then use a scale factor, you have my blessing. But proportions, I think, are a little bit easier, at least for most of us, right? Okay, you have to have a ratio you already know. If this is more helpful for you to start with like the one you're trying to find, that's a good idea. So we know x corresponds to 20. Please remember that you had the small side over the large side. Okay, x corresponds to 20. That needs to be equal to another ratio that's the same. So 9 corresponds to 12. You could use that one, or you could use 12 over 16. It doesn't matter. I'm going to use 9 and 12. Now I need you to cross multiply and solve. So that's 12 times x is 12x. 9 times 20, get a calculator if you need to, is 180. If you divide by 12, because you're undoing the multiplication, then x would be equal to 15. This process here, this is what we're doing a lot of in the rest of this unit, is can you find the missing side by writing a proportion and solving. All right, that's all I have for you today. Please make sure that you've got all the information you need. If you need to go back and listen to something again, then go for it. But your assignment is on Big Ideas Math. Thanks.